Hi. Right, here we go with graphs. So from what I understand, this is kind of your first work with graphs, really. I think it's probably the first time we've really looked at them as linear graphs, at least, not things like bar charts and things like that, which sometimes get mixed up with them. So we're going to start off with something that's fairly straightforward, but the more complicated things we do, people tend to forget this part, okay, and they suddenly panic about it, okay. So I want to make sure we're really happy about doing these first before we do anything else. We're going to look at the graphs of, well, there's a variety of them here, but they're straight lines. They're called linear graphs, and the first one we're going to draw is the graph of x equals 1. Okay, I'm going to use a felt tip just so you can see. Space pencil, it's not going to show up enough. But you need to make sure you've got a ruler. Turns out when they say shatterproof on, they mean it, because this doesn't say that, and I had a bit of an accident with it. So the first one here, x equals 1. What we're looking for on our graph, it's every point where x, our x coordinate, equals 1. Okay, so I'm going to come along here and say, let me pick this point here, just as an example. And the coordinates of that point are 1, -3. Okay, I'm going to pick maybe this point up here, where the coordinates are 1, 7. Let's get another one, this one here. Coordinates are 1, 2. Okay, so whichever point, I've picked those out at random, but what you can probably see is our x coordinate is always 1. Anywhere on that vertical line there, our x coordinate is going to be 1. So from that we can draw the line x equals 1. Okay, that's all there is to it. That is the line x equals 1. You don't need to do these parts. It's just to show you why and how. I wouldn't, if you struggled with it a little bit, I would certainly suggest or recommend using a couple of these, because people quite often draw them the other way around, and they'll draw it here but parallel to the x-axis. Really easily done if you're not concentrating properly. I've certainly done it in the past, so just plotting a couple of points will just help a bit with that. So let's try the next one. I'm going to do the next one. I'm going to do the graph. Oh, hoping you can see this. I know it's a little bit blurry because I've had to zoom in so far. In fact, it's a little bit better. I'm not sure. Hopefully you can see. So next we're going to draw the graph, or the line of x equals -3. Okay, so we're going to come along our x-axis, that's this horizontal one here, all the way to -3, and draw a line through there, straight line going vertically up, and just make sure you label it afterwards as well. Okay, so that is the line x equals -3. That is, again, reminding ourselves we can go anywhere on here. This is the point -3, 3. Down here we've got the point -3, -7. Anywhere on that line, our x coordinate is going to be -3. Okay, now I'm going to do two in a similar way, a bit different, but works the exact same way. We've got some here. I'm going to do y equals 2. Okay, so I want to know now where I can draw a line where the y coordinate will always be 2. So like I did on the first one, I'm going to plot a few points here. We've got 2, 2, and then we could have 6, 2. We might have down here 2, -3. Okay. Oh, sorry. -3, 2. Okay. And this is what I mean. It's so easy to slip up on these. And here we've got, just pick another colour to show, point these out a bit. Our y coordinate is 2 on every single one of those. Okay, so that shows us the line that they're all on is the line y equals 2. Okay, so just line that up. There we go, straight through. That's line y equals 2. And the last one we're going to do just another y one, but with a negative in, y equals -4. Okay, so we want to know where on this line everything is going to equal -4. And absolutely right, I'm sure you can see by now it's going to go straight through -4 on the y-axis. Okay, y equals -4. Any point on there, y is going to equal -4. Okay, right, I'm going to do one more thing. And like I say, these seem quite straightforward, and I'm sure you guys are probably also thinking it seems quite nice, this. they're going to get much more complicated, and once they do, suddenly people forget how to do this. They panic. Compared to what we're going to go in, which is much more difficult, if we come back to these, they seem a bit more complicated just because you're overthinking it, okay? So just try and keep those in mind. We'll come back to them at some point. I'm going to do one more now, one more graph. And this is a really important one, and this is what's going to lead us into everything else, okay? And this is the graph, or the line, y equals x, okay? This is brilliant. This is what everything else comes back to. Everything else we're going to do now comes back to this, okay? So y equals x, what we want to do is find something where the y coordinate is always the same as the x coordinate. Okay, so for example here, 1, 1. Y equals x, they're the same. X equals y there. Okay, they're exactly the same. Find another one, 4, 4. Okay, they're the same. And that's what we're going to do. We're just going to plot a few more points. So we could have -3, -3. The same coordinate. -6, -6. And what you get is a lovely line that goes through here. And it kind of cuts it up almost, well, it is symmetrically. Across there, let's have a look. There we go. Okay, so that is the line y equals x. And it is so important that you're happy with that one, because all the others come back to this. Okay, they all relate back to this one. I'm going to do one more. I just thought of it, and it's a nice one. It comes off this one here as well. I'm just going to do this one up here. Y equals -x. Okay, just one more of these. Y equals -x. So this time we're looking for points where we've got y and it equals the opposite of x, okay, the negative of x. So if y is 1, we want x to be -1. Okay, I'll just write that in there. So -1, 1. If y is 4, we want x to be -4. So down here, we've got -4, 4. Don't forget our x coordinate comes first. Easily missed out there when these are written y then x. When y is -4, x is +4. Okay. Okay, and that gives us a lovely line, which is the mirror reflection, the mirror image of y equals x. Okay, if we reflected it in the y-axis, that's what we'd get. Okay, so that's the first few. I've already set you a sheet to do where you're going to substitute in some values to draw different lines. You should be quite happy with those. It's simply a kind of filling in the boxes exercise. But alongside that, please make sure you're really having a good look at those, okay? Also, the Desmos things I've asked you to do, so that's on the website, Desmos. Have a play with that, okay? Just draw different lines. Keep on putting in different equations. I've given you a list of ones to try anyway. I have given you a list to try, and just see what happens. Mess around with it a little bit, okay? Because the more you do that, it's brilliant, because what it does, it plots the graph for you, so you don't have to draw it like this every single time to be able to compare them. You can just plot it in the computer and see what happens if I change this number, what happens if I change that number, what happens if, let's just flip this over, I plot y equals 2x, and what happens if I plot y equals 3x. Okay, what's the difference going to be? What happens if I plot y equals 2x plus 4 and y equals 2x plus 5? Have a look at it, okay? I don't want to particularly tell you these. It'd be much more beneficial if you can kind of discover them for yourself, because that way you're going to remember it. Okay, so have a play around with it. There's just a couple of things to try, but I have already sent you some others to have a go at as well. Please get in touch if you've got any concerns about that. Thanks, folks.